Surf for the North Pacific while El Nino builds. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Saturday, November 4th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Just click the Stormsurf icon down in the lower right-hand corner of the screen. You'll get all signed up. Ring the bell. You'll get automatic notifications when the videos are posted, typically on Sunday evenings. Yes, we're doing it. We recorded this a day ahead of time, but we're going to post it on Sunday. Life takes over sometimes. And if you'd like to make a contribution, you can. Click the special thanks button down below, the heart with the $sign on it. And with that, I'd like to thank the folks that donated last week. Tim Caston, thank you. Coach Nate, Jason Odom, you guys on it every week, it seems like. Thank you very much. We appreciate it. And then also, E. Slate, Ken Antel, Evolution Moto, Noam Chonky. Thank you very much for your contributions. It is greatly appreciated. And also, if you want to go right to the El Nino section, just move ahead to about the 15-minute mark. Look in the index over on the right. You can figure it out pretty easy. And also, we're going to do just a little quick thing talking about the Jetstream and rainfall across the southern tier states and potential impacts from this El Nino. Quite a few people have been talking about it on the comments. So I just like to do, just a couple of minutes and go through that real quick. All right. Let's get to work. We'll start by looking at significant wave heights for the North Pacific Ocean. And yes, we actually have two gales. You can see them, 23-foot seas off the Pacific Northwest, and another gale developing with almost 24-foot seas north of Hawaii. We're starting to get into a little pattern. This is good, and consistent surf, hopefully, is on the way. But first up, a look at current conditions. We'll start by looking at the buoys in Northern California. Point Reyes buoy, number 029. We're looking at all the energy that's hitting that buoy, all the way up from 33.3 second period, really long period energy, which there is none, all the way down to 5 second period. That's basically wind chop. I mean, it's really about 6 seconds where you can get something that's decently rideable. The preference is 13 seconds or above. We don't see any of that. We see mainly wind swell in the, anywhere from 9 to 11 second period range. Taking most of this energy under the curve, we can assimilate it and see the primary swell is 3.6 feet at 9 seconds from 270 degrees. That's surf at about 3.2 feet, which is about waist high, and that's about what it is. And it says secondary swell 1.6 at 12.4 seconds, but just looking here, you see it's all part of pretty much the same mess of swell. Okay, the other thing here, chop height, 1.1 feet. And that's all the energy from 2 to 5 seconds. So that just gives you, if the number here is 1 or in the 1 to 1.5 range, that generally means there's not a whole lot. But when it's up to 2.5 and 3 feet, then that means that the surf is really ugly and messy and not that good. So it's a sort of a cleanliness indicator. Let's go down to the south end of San Diego, Southern California. We're looking at buoy 191, the Point Loma South buoy. And again, looking at all the energy, there's a little tiny bump here at 20 seconds, but a third of a foot, probably not even noticeable. And again, that same sort of profile, wind swell in the 9 to 12 second period range. Primary swell 1.9 feet at 12.1 seconds from 247 degrees. That's thigh-high surf. And then there's this other secondary wind swell 1.8 feet at 9 seconds. Again, it's all part of the same thing. There are waves at maybe chest high at top spots on Saturday, but mostly pretty small. And again, the chop height indicator 0.8 feet, so quite clean. Then we blast over real quick to the north shore of Oahu, Waimea Bay, buoy number 106. Again, that same sort of profile, just wind swell showing up in about the 9 second period range. Primary swell 2.8 feet at 9.6 seconds from 326 degrees. This is left over from a swell that hit yesterday. That would have been on Friday. Surf height 2.7 feet. You'd think waist high, but there's still some chest high set sort of thing. And the chop height 1.6 feet, so a little bit of bump in the water. So what's going or has been going on in the ocean for the past couple of days? We're going to Thursday, the 2nd of November, so 2 days ago. Little gale started building, the first in a series north of Hawaii, not doing a whole lot. Pushed a little bit of swell south towards Hawaii, and well, you'll see this in a second. Seas building to 18, 19 feet on Friday, 20 feet, but all off the U.S. West Coast. You see the leading edge of some energy about ready to push into Hawaii, which hit on Saturday. That's today, the 4th of November, but size was pretty minimal, chest high, like what we were looking at the buoys. Most energy pushing northeast up into the Gulf off of the Pacific Northwest. And where are we? 12Z on Saturday. What is that? 23-foot seas right there. The highest seas over this entire domain. And maybe let's get one more reading off of this. There we go. 23 feet again. That swell bound for California in on Sunday and Monday. But another gale has started developing off in the Gulf. In fact, we'll go back. Just there, just started today. Saturday, you see 20-foot seas, and then what were we up to? 24-foot seas, so maybe a little bit better push from this one. All right, so what's coming? So let's go start up at the jet stream. These are jet stream level winds. These winds help support the formation of gales, and when they form, help direct their track. We're looking for a dip in the jet, and if ever there was a dip, it's right there. Winds falling south and then going off to the northeast. This helps create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure in the northern hemisphere. And of course, low pressure, if it's strong enough, generates winds. Winds, as they get traction on the ocean surface, generate seas. Seas, as they radiate away from the fetch area, get groomed out. The shorter period elements of the swell drop off, exposing the longer period elements. That swell, when it hits your beach, produces surf. All right, so we have a decent jet stream flow. It's kind of split over the West Pacific, but then comes together nicely on the date line right here, right where the Walker circulation is falling down. We'll get into that a little bit later, but this is no big surprise. During El Nino winters, typically the dateline region, the Gulf of Alaska, really fires up, very supportive of gale development, and that's what we have here with winds at 100 and almost 100, 160 to 170 knots. Also notice the tip of this flow about ready to plow into northern California and we'll say Oregon too, an atmospheric river event. This is sort of maybe a harbinger of what's to come. The position of the jet stream is real important in determining how much rainfall gets into not only California and the southern tier states. We'll get into that in a minute. Anyway, looking forward as we go into Sunday, pretty much the same flow continues. Supportive for gale development here in the Gulf, then pushing onshore into Monday. But notice this, look, the jet very energetic, but ridging hard north up over Kamchatka, then falling hard southeast again over the northern Gulf as we get into Tuesday, the 7th of November, creating yet another trough supportive of gale development as the original portion of the jet pushes inland. More support for gale development. Then that trough there eventually pushes in, we'll say Friday sometime over California. But then it looks like yet another trough is to start falling south. So it looks like we're into what they call a progressive pattern when you have storm after storm after storm, or in this case, weak gale to a moderate gale to maybe something more long term. This is looking much better and suggests surf is on the way for quite a while. All right, so down at the surface, here's gale number 1 producing 35-knot winds pushing into the Pacific Northwest. Things are pretty washed out, messed up there, but there is swell from that already hitting Hawaii, working its way towards California. Gale number 2 firing up north of Hawaii, maybe some sideband energy for the islands, but the main focus here is the west coast of the U.S. That gale starts fading out as we get into Sunday and Monday. Yes, 20 to 25 knot winds, but that, we really want 35 knot winds over decent size area for a decent amount of time. Gets you a nice 13-second period swell, and that is true ground swell. As we get into Tuesday, gale number 3 sets up with 35 knot winds, maybe a little bit more in the Gulf of Alaska into Wednesday, getting traction, offering hope, and then yet a stronger one Thursday into Friday in the northern Gulf of Alaska. All this looking pretty good. So we look at the significant wave height chart, the effect of those winds on the ocean surface. The GFS wind model that you just saw creates the traction, creates the seas. Then this wave model, or this model, picks up on that and then calculates how big the seas will be and the resulting swell that will result from it. All right, so we know we have 23-foot seas off the Pacific Northwest on Saturday. We have a new gale right there trying to organize. There's the little dot, 20. No, that's not right. That's 24, 22, 24, 20, we'll say 24-foot seas right there as we get into Sunday off the coast of California and then fading. You see a little bit of a front trying to push into Hawaii, but most of the energy bound for the U.S. West Coast. Things mellow out. Then here comes yet another gale with 20, 22, 24-foot seas. The northern Gulf building to 28.3 feet for a little bit there, traversing the northern Gulf. Longer period swell, you can already see the front from it starting to evolve. And yet another gale as we get into Thursday, the 9th of November, builds over the North Dateline region with, what do we got, 34... And I think we go back up. No, 32-foot seas and fading from there into next weekend. Swell from that, pushing towards the U.S. West Coast with sideband energy for Hawaii. And then we're out a week. Things settle down from there. So a quick look at local winds. California here, Hawaii right here. Trades in control and a light foggy regime Saturday, at least for the Northern California coast. Put this in motion as we get into Sunday. A light south wind event, mainly for Northern California, approaching front here. Trades building for the Hawaiian Islands as we get into Monday. Looks like northwest winds or some sort of cold front hitting Northern California. Notice this stronger high pressure here, building trades for the Hawaiian Islands. That's the theme for several days here. Front blows through, northwest wind set up for the California coast on Tuesday, and probably blowing pretty brisk, while trades continue pretty solid for the Hawaiian Islands, all driven by this high pressure system moving off to the east. On Wednesday, you see 20-knot north winds, maybe not onshore for North and Central California, but certainly enough to take that chop factor that we were looking at on the buoys and push that up probably into the 2.5 and 3 foot range. Solid fetch of easterly winds, likely making east wind swell for east-facing shores of the Hawaiian Islands. Trade winds in control. Another gale up in the Gulf of Alaska. As we get into Thursday, northwest wind regime backs off a little bit for California. Trade still solid. Another bout of high pressure setting up. So we get into Friday. Here we go. Next blast northwest winds for California. Trade still solid for the Hawaiian Islands. Gulf gale continuing, and then we're into Saturday, and it looks more the same. High pressure in control. Quick look at precipitation for California. So there's the dividing line right there between California and Oregon, the Bay Area down there, Point Conception there, Southern California there. See a front off the coast, maybe a little bit of rain for Cape Mendocino Saturday night going into Sunday. Trying to work its way south Sunday to the Bay Area, maybe not even reaching Santa Cruz, and all that precip pretty light unless you're up in the Cape Mendocino area. Continues on Monday, and look at that, even a little bit of snow. We're not even going to look at the chart. Roughly maybe a foot of snow for higher elevations in the Tahoe area and down into the Mammoth, that kind of area. Then things start drying up as we get into Tuesday along the California coast, and high pressure we know taking control. A little bit of precip maybe as we get into Friday, but that quickly evaporates, doesn't even make it south to the Bay Area, and there you go. Hikers temperature forecast for the area where the Tioga Pass Road intersects with the Pacific Crest Trail at about 8,700 feet. You can see the line right here. This is the temperature in the atmosphere from up to 14,000 feet all the way down to, well, if you had sea level there at that location. And you see generally at that line where the PCT and the Tioga Pass Road intersect. Right now, temperatures in the 45-degree range, but quickly falling as we get into, I would say, Monday Monday evening and afternoon down to 25 degrees or so, and hanging in the 25 to 30 degree range even into Thursday. So the whole early part of next week, quite cold, and continuing into, so below freezing, continuing into the whole weekend. So all of next week below freezing, then temperatures warm up. So it seems reasonable. Little bout of snow up high, probably not a good place to be hiking, especially above 10,000 feet, something like that, as these fronts come through in the early part of the week. Could be quite breezy, and certainly you don't want to be trudging through a foot of snow. All right, so let's put this all together. Spot forecast for Ocean Beach. Oh, there we go. Surf spot forecast, Ocean Beach. These are surf heights, and as we get into Saturday afternoon and into Sunday morning, you see surf heights in the 8-foot range from that new approaching swell. Another pulse of swell in on Tuesday. But when you start seeing these dropouts, that also means a lot of wind and a lot of bump. But you see that. And then theoretically, some more swell as we get into next weekend. Let's look at specific swell heights. 6.5 feet at 12 seconds on Sunday. Another pulse pushing up to maybe 8 feet at 12 seconds on Tuesday. That all fading out. Then next weekend, 6.5 feet at 13 seconds. So 3 rideable swells for the Ocean Beach area. Not really looking at wind, but here's your wind indicator right here. You see as the swell drops out and the wind's up at 20, 23 knots, probably not a good surf day. We go down to San Diego. Now, a lot of the swell, of course, is going to be shadowed by the Channel Islands. We see a little bump of surf somewhere in the 2-foot range as we get into later Sunday and Monday. Another bump up there in the 3 to maybe 4-foot range, but again, you get these dropouts sort of suggesting wind swell. And then a little bump up next weekend. Specific surf heights or swell heights, we're looking at, what do we got? 1.5 feet at 13 seconds or so. Yeah, 1.5 feet, 10 seconds on the first one. Maybe 3 feet at 12 seconds with a bunch of wind swell, 4 feet at 6 seconds mixed in. And then the following weekend, 1.9 feet at 11 seconds, something like that. So something rideable, not a whole lot nothing happened in the southern hemi. So really it's down to we need surf and we need larger gales sinking further south in the North Pacific. And then finally we go over to the north shore of Oahu, swell fading there, or surf heights fading from 4 feet from the current swell it's hitting. Another bout of swell in on Monday, surf heights in about the 4.5 foot range. Then another batch of swell in for Friday and Saturday at, again, 4.5 feet. Looking at actual swell heights, 4 feet at 10 seconds to today, I think that's what we were seeing. Then another bout of, we'll say 4 feet at 11 seconds or so on, Tuesday. That fading out. And then another little patch of 3.5 feet at 12 seconds. Most of these gales, at least the initial round of them, pretty much pushing off to the east, bypassing Hawaii and focusing on the U.S. West Coast. But as we get deeper into the forecast period with gales setting up on the North Dateline region, that will offer better opportunity for the Hawaiian Islands. All right, let's go take a long-term outlook, see what's going on. The two major weather factors or oscillations that affect long-term weather are the MJO, the Madden-Julian Oscillation, and the El Nino Southern Oscillation. So I found this nice little graphic. It just came out maybe a couple days ago. This is a chart of snowfall during all El Nino winters, January through March. And no big surprise, the precipitation, here we go, we'll drag this up here, is where the blues are is difference from average of snowfall in inches. And you can see the southern tier states getting much more precipitation, snowfall, frozen precipitation than normal, whereas up north, less snowfall. Now, this doesn't necessarily equate to rainfall, but for our purposes, I think it does. All right. What happens, just like what you saw on the previous chart, in fact, let's see if we can pull that up. You see the jet stream pushing into North California. This is really typical kind of classic El Nino sort of thing. You get the jet stream, it pushes further south than normal, and it pushes into California somewhere between up here and down into almost Southern California. It sort of wiggles. It starts north as a front and a storm moves through, pushes further south, and it pushes deep into the southern tier states. When it does that, it also taps warm, moist air here, dragging it up with it, and that creates rainfall. Okay, during El Nino, this is known as an atmospheric river. During El Nino, the jet falls further south. In like La Nina winters, it slams into the Pacific Northwest and bypasses California. Hence the drought and the lack of snowfall that we had the past two previous years. Last year was a transition year. Now, the point being, this jet stream doesn't stop at California. It continues on over Arizona, Nevada, New Mexico, Colorado. The exact position of the jet and how far south it goes is what is the variable that drags precipitation like into Texas. We've had several folks on the comment section worried about, are we going to get snowfall or rain in Texas and southern tier states? And so the answer is you can't definitively say, but typically the stronger the El Nino, the more atmospheric river events you get. The further the jet falls south, the more rain that comes into Southern California especially, and therefore that's a good proxy for what's going to go on in the states that are due east of there. Not 100% accurate, but it sort of gives you an idea. So back to our chart here, snowfall during all El Ninos, weak, moderate, or strong. You see that range from really the Oregon-California border down to somewhere around Point Conception. That's really the Sierras right there. But you also see above average snowfall way down into here. Now they show snowfall here in Texas, but if it isn't snowfall, it's certainly going to be rain, and probably the dividing line is somewhere in the middle of the state of Texas. I mean, other than that, I mean, a lot of rainfall in Texas. I'm not a Texas expert, but a lot of it is also monsoon flow and rainfall coming up through the Gulf of Mexico. All right. Now, the snowfall, oh, you can't see this. Let me drag this down. There it goes. Snowfall during moderate to strong El Nino winters. And this winter, the expectation is that we're going to have a minimum strong, moderate, if not a mid-grade strong El Nino. The thought being the jet stream will fall further south. You see little bits of snow here into Southern California, southern tier states. I mean, it's pretty much a copy of what we saw in the other chart, but a little bit more snowfall, a little bit further south, and more rainfall. So the short of it is, that's the expectation. The jet stream will roar in somewhere between here and down here. We think more in this central, from like Lake Tahoe south down to Point Conception. That will be the main focus, and right across this line here. But you get a good band on either side of that of snow in higher elevations, rain down low. The jet stream should push the whole way across the southern tier states and then create big low pressure systems that wind up off the northeast coast, and then head off towards Europe, and then England and that area also gets a dose of the same energy. Not as strong a correlation, but more energy fueled by El Nino. So that's our answer to the question. All right, now off to the discussion on the MJO, the Madden-Julian Oscillation, that periodic weather oscillation that rotates around the planet. There's two phases to it, the active and the inactive phase. They're both doing something at the same time. The active phase is typically on one side of the planet, the inactive phase on the other side. They rotate west to east around the equator. The active phase acts like a low pressure system, the inactive phase like a high pressure system. High pressure systems dampen potential for precipitation, and they also increase trade winds. It's just stronger high pressure. The active phase of the MJO is the one we're really interested in. That's the low pressure system. When the active phase is over the far west Pacific, because it's a low pressure system, it draws up moisture, warm moist air off the far west Pacific, sucks it way up into the atmosphere. That warm moist air adds energy to the jet stream. A stronger jet stream creates troughs. That creates storms, which then in turn create surf and also create weather and rain and snow as they push into the California coast. The active phase feeds this energy to the jet stream, just like we were talking about. The atmospheric rivers pushing into California, all that sort of thing, typically is fueled either by a strong El Nino, which is the equivalent of multiple active phases of the MJO all stacked together, or it feeds just the active phase of the MJO, which does all the things we talked about before. The other thing is the active phase of the MJO dampens trade winds. High pressure increases trade winds, low pressure dampens trade winds. So we're looking at a chart here, data from the TAA buoy array, a series of buoys strung across the equator used for monitoring El Nino. They have wind sensors on them. Here's the East Pacific here, West Pacific here. Here's the equator. That's New Guinea right there. The date line's right there. We're just looking at the arrows. They show the wind speeds and direction. Pretty strong out of the east over the East Pacific. New Guinea's like right off. Ecuador's like right off here. Central Pacific, Hawaii's like north of this up here. This only goes 10 north to 10 south. Moderately strong over the Central Pacific to about the date line, and then you see these little arrows starting to show up out of the west. Suggest trade winds, if anything, are almost reversed. But it's not the actual wind speeds, it's the anomaly, the difference from normal for this time of year. And you see, yeah, those winds are strong, but they're no different from the average wind speed this time of year, so that's pretty much neutral. Maybe just slightly stronger than normal over the Central Pacific, but in the West Pacific, literally the anomalies are weaker than normal, suggesting westerly anomalies, suggesting maybe some sort of weak active phase of the MJO or an El Nino base state. They're almost interchangeable. If you have long-running westerly anomalies, which we've had, that typically is a sign of El Nino, and what happens is the MJO starts fading away and disappearing as the El Nino base state takes over, because El Nino basically is like a long-running active phase of the MJO. Next up, the forecast for the next 2 weeks. Very good news in this forecast if you believe the GFS model. But first, let's get ourselves oriented. 850 millibar zonal wind anomalies. That's the east-west component of the wind. Reds and yellows are westerly anomalies. It's typically associated with the active phase of the MJO. The blues, purples, easterly anomalies. Okay, but let's get ourselves oriented. This is the whole planet. The date line is right here. So all we care about is the far West Pacific. West Pacific starts 125 east, so right there, that'd be like New Guinea on the equator. And the Kelvin wave generation area, the area where when the active phase of the MJO is over the West Pacific, it not only dampens the trade winds, but it allows warm water that's normally sequestered over there, held by strong easterly trades. Well, if the trades dissipate, that warm water starts sloshing to the east, right? That's known as a Kelvin wave. It's like a ball of warm water. It travels under the equator, not on the surface, but under the equator, the whole way across the Pacific. Takes maybe 4 months to make the trip. Eventually, that Kelvin wave, that ball of warm water, impacts Ecuador and the Galapagos Islands, gurgles up to the surface, creates a warm water slick. If you have another active phase of the MJO, and typically the MJO is like 6 weeks on, 6 weeks off. So 6 weeks later, another active phase shows up, can do the same thing, and you get another Kelvin wave. If you get multiple Kelvin waves all stacked up one behind the other, that is the harbinger. That's what helps set up El Nino. We've had 6 active phases since late December of last year that have created 6 Kelvin waves. All the warm water from that is balled up off of Ecuador, gurgling to the surface, and then getting caught by lighter than normal trades and pulled back to the west across the equator. That is the classic El Nino symptom. And look at this. We have another big, fat westerly wind burst now forecast starting, a day or two from now and going into past the middle of November. Strong westerly wind bursts. We haven't seen one this strong in quite a while. This is a sign, we think, if it happens, of El Nino getting coupled with the atmosphere. The ocean's changing, the atmosphere is responding in kind, creating a westerly wind burst. This might set us up for Kelvin wave number 8. That would be awesome if it were to happen. So things looking good in that front. Also notice this massive pocket of easterly anomalies. So this is over like the Indian Ocean somewhere. We think what's going on, we've talked about this, the shift of the Walker circulation. I'm not going to get too down into the weeds here, but the far West Pacific is right here. It looks like air is falling down over the West Pacific, then splitting, going to the east towards the dateline here. That's creating these westerly wind bursts, and then going the other direction into the Indian Ocean. We also think the upward branch of the Walker circulation is probably somewhere around here on the dateline, maybe just east of it. So you have downward dry falling air splitting, putting dry air pushing across the West Pacific, and then that dry air starts picking up moisture from the West Pacific, and then when it gets sucked back up into the upward branch of the Walker circulation, that warm moist air will start to fall out in the form of clouds and precipitation, and then eventually both of these start shifting off to the east as you get into a mature El Nino situation. We will be talking more about that in a second. Next up, outgoing long wave radiation forecast right there. Cloud cover is all it is. Oranges are dry air, blues are wet air. Typically I go, that's the inactive phase of the MJO, that's the active phase. And let's get ourselves oriented. South America, Central America, Hawaii, New Guinea, equator right there, dateline right there. Okay, so this looks like dry air in the inactive phase of the MJO. But what this pattern has been on this chart, in fact, for the past couple of weeks, it was nothing but oranges the whole way, just sequestered in the West Pacific. What I really think is going on, the downward branch of the Walker circulation hitting somewhere around 120 right there, and then creating these westerly anomalies that go out to the dateline, then get starting sucked up in the upward branch of the Walker circulation. That downward falling air is dry, and you get this sort of dry air pattern. Not the inactive phase of the MJO, the Walker circulation. You see it pop up again here. This is a statistic model, 15 days out. You also see this wet air pattern setting up somewhere around the dateline. I don't think that is the active phase of the MJO either. I think it's cloud cover from the upward going branch of the Walker circulation. Now that's the statistic model. The dynamic model, here you go again. Dry, dry, almost dry, dry with building wet air. Again, we think the models are really not, we typically use this to look for signs of the active and inactive phase of the MJO, but now it looks like the Walker circulation is taking control, and we have a permanent sort of inactive, active phase setting up across the Pacific. Maybe. I've only seen this for a couple days on the charts, but it sort of smells like that's where we're going, and if that's where we're going, that's a really good thing. Next up, phase diagrams. These are just drill down and show you details where the active phase of the MJO is. How do you read the chart? Active phase moves from west-east from the Indian Ocean to the Maritime Continent over the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is now, so supposedly it's in the far West Indian Ocean. Very weak. Forecast according to this model to two of the three members say making it to the Maritime Continent. One says basically coming back 2 weeks to where it is. Basically, no MJO signal. The dynamic model, the GEFS model, says active phase building to moderate status, weak to modest status in the East Pacific like a week from now, and then crashing back and doing nothing. So all this smells of an MJO that is non-existent, and probably an El Nino base state that's taking control. The upper level model showing, and this is a statistic model, which is probably not great at managing the El Nino situation, but we'll look at it anyway. Areas favorable for precipitation in green, dry air, and yellow. One normally could say the green air is the active phase of the MJO, and the yellows and orange is inactive phase. And there's still some like really low level MJO signal going on. You'll see it in some of these other models, but all it is doing is basically it nudges El Nino a little bit stronger at times when the active phase syncs up with the El Nino base state, constructively interferes with the El Nino base state, they could say. And then when the inactive phase pushes over the far West Pacific, that destructively interferes with the El Nino low pressure base state, sort of dries things up. So, South America, Central America, New Guinea, equator there, dateline here. Each panel 5 days, goes out 8 different panels, so 40 days. Weak active phase in control now, or at least wet air, drying out somewhere at the end of November for a little bit, and then you see moisture creeping back in as we get into the early part of December, back to a sort of a active phase state, weak, but notice all of it exceedingly weak, suggesting the El Nino base state in control. All right, we'll go out even further. This is a month from, looking out a month from the CFS model, 850 millibars zonal wind anomalies. Dateline runs right up the middle. The reds are what we want to see. Those are westerly anomalies associated with, theoretically, the active phase of the MJO, but MJO is black. There's the last real active phase we had. There's a weak inactive pulse, but since September, there's been nothing but, look, continuous westerly wind burst, westerly pulse. You know, they kind of alternate. These red lines are equatorial Rossby waves. They constructively and destructively interfere with the El Nino base state as well. But here we go. November 3rd, westerly anomalies in control, forecast building. Notice there's a little inactive phase of the MJO. It would have started up here. It basically got ripped apart going through the Kelvin wave generation area and only started to show as it went. So this is California, south of California on the equator. So it's showing a little bit there. Notice here's your active phase of the MJO. This is likely being influenced by some active phase here for the next 1 and almost 2 weeks of westerly anomalies. And then all that moves south of California. Westerly anomalies strong south of California. That should certainly suck the jet stream into California. Could be a big red X for precipitation right around mid-November or so. Then notice inactive phase supposedly setting up, the last weekend, right around Thanksgiving. Westerly anomalies still there, if not neutral, but we'll see how this all plays out. All right, continuing on. This is MJO, but we're looking at outgoing long-wave radiation. We're about ready to go look at a model, but let's just see what's actually been happening for the past couple of months. So the blues are cloudy skies. The oranges and reds, cloud-free skies. Dateline runs right up the middle. So New Guinea would be over here. Maritime continent somewhere over here. We're going back a year. A year ago, we were in La Nina. Cloudy skies over the maritime continent. Bone dry air locked over the dateline. This would be high pressure. This would be a low pressure bias. Somewhere around April, May, it all fell apart, and notice particles or little blobs of wet air moving more towards the dateline as we got into July. A building wet pattern on the dateline. Today, that pattern continues to build, and maybe not as strong as I'd like to see it, but also notice the dry air pattern here looking as strong over the maritime continent right now as it was over the dateline less than a year ago. A clear sign that that upward branch of the Walker circulation we talked about, air sucking up over the dateline and then falling down dry over the maritime continent. Again, a classic El Nino kind of indicator. And this is actual data. It's not a model. It's not a forecast. It's what's happening right now. Looking good. All right, now here is the model for outgoing long-wave radiation. This is what's happened in the past here. This is the forecast up here. Highly idealized, but you see, and let's get oriented here. Dateline running right up the middle. The blues, less sunlight reflectivity off the ocean surface, inferring clouds. You see, even here's your actuals of the blue pattern, September. I mean, just steadily building more density of the blue of the clouds in the dateline area, and now getting really solid pretty much the whole way through October, getting into November. Likewise, cloud-free skies building over the maritime continent and getting only stronger. You see the intensity of the clouds building forecast as we get to Thanksgiving, and then continuing to build while moving off to the east to a point at about roughly 150 west. So this would be the center where the upward branch of the Walker circulation would be on the equator, basically due south of Hawaii. That would feed the jet stream falling south in that area, really fueling storm development theoretically in the Gulf of Alaska and that area. Now we do the same thing, but we're going to look at surface level wind anomalies, 850 millibar zonal wind anomalies. That's actually up at about 4,700 feet, but a good proxy for what's going on at the surface. Oranges and reds, westerly anomalies, blue, easterly anomalies. The same pattern. This suggests here building notice the westerly wind pattern in the far, just barely in the West Pacific back in July, steadily moving off to the east. On the date line right now, forecast continuing build, peaking somewhere in the December timeframe, and then also moving off to the east. The center of it, actually, the leading edge of it, somewhere right about there. Again, about 150 west. So this suggests that those winds coming in from the west and also east winds on the equator going up into the upward branch of the Walker circulation, maybe somewhere around here, but right now that's probably just about right on the date line. You also see this east wind pattern, the downward branch of the dry downward branch, just raging hard over the Indian Ocean and maritime continent right now. But as we get into December and January, that dividing line starts moving into the West Pacific, signaling the beginnings of the end of El Nino. Still a couple of months off, but still probably the beginning. This blue at some point will set up on the date line, and then we'll be back in La Nina. Not looking forward to that. Now, let's overlay the MJO, the Madden-Julian Oscillation. All right, so the MJO still exists even though we're in an El Nino-based state. The dotted contour here, the inactive phase of the MJO, forecast for now for not even the next 2 weeks. And then the active phase, very weak, but still westerly wind anomalies strong. Notice this model doesn't even show that massive burst of westerly anomalies that are forecast by the GFS model at the same time. So the suspicion is these westerly anomalies might be a lot stronger than what this model, I mean, it's a general model. It's like using a 4-inch paintbrush when you're trying to paint something that you need like a 10-haired camel brush to do some fine detail if you're a painter. And then we get into another, so the active phase, this would be pretty much the whole month of December. January, inactive phase, another active phase after that, but westerly anomalies continuing, the easterly anomalies pushing into the West Pacific. All right, and then finally, the low-pass filter. This is a good one. The low-pressure bias, the El Nino indicator. 1, 2, 3 contours in control today. The fourth contour starting, holding for the foreseeable future. This would be the center of the upward branch of the Walker circulation. Today, where is that at? About 175 west, so just a little bit east of the date line. And according to this, holding pretty steady in position, but I bet you it's going to start shifting over at some point. The high pressure bias fully set up over the maritime. Well, this is actually the Indian Ocean. There were 2 contours last week and the week before. That's gone now. There was a 5th contour in this. So the model, I mean, it fluctuates day to day, and it's sort of these things like the 5th contour and the strength vary a little bit. But in general, there's been no particular change in this model for months now, all indicating El Nino on track. All right, so what's going on down in the ocean? We've talked about the MJO, the MJO and the El Nino base state, which are the driving factors for the atmosphere. The first thing that those things affect is the creation of Kelvin waves, right? And we're very interested in that. So this is data from the TAO buoy array. Again, those buoys strung across the equator used for monitoring El Nino. That's the East Pacific there. That's the West Pacific. Notice these little X's. Those are sensors on the actual anchors of the buoys. Now notice right here, a bunch of the sensors are out. And then there are whole lines of the buoy array that are down. But you can take these disparate little bits of censored data, use a model to fill in the gaps. You get a profile of the water temperature down to 300 meters in the ocean surface. We're looking for Kelvin waves, those balls of warm water, big lumbering large amounts of warm water pushing off to the east. So the 30-degree isotherm, that's 30 degrees centigrade, that's quite warm water. The leading edge of it is about where it was last week at 178 west. The 29-degree isotherm, about where it was last week, give or take a degree or two. 28-degree isotherm hadn't changed at all. The 24-degree isotherm, if anything, has got maybe 4 or 5 meters shallower than it was last week, but all suggesting in general piles of warm water pushing the whole way across the Pacific. Now, this is the means. It is the anomalies that really tell the story. And if ever there was a picture of Kelvin waves and the effects of multiple Kelvin waves, this is it. Normally you have cold water here, warm water here, the trades blowing hard. This would be Ecuador and Peru here. Cold, lots of offshore winds, east winds, just trades, create upwelling cold water up to the surface. But no, the trades are weaker than normal. We've had 6 Kelvin waves in flight. They've all built this massive pool of 4, almost 5-degree anomalies here off the Central American coast. And then look at this. We have a big pocket of 3 degrees. It was just 2 degrees 2 weeks ago and a couple of weeks before that, now building to 3 degrees. Continued westerly anomalies just dumping warm water off of New Guinea into a building pool here near the date line. This looks like Kelvin wave number 7, maybe even Kelvin wave number 8. It's hard to say. It's just it's a fire hose of warm water moving off to the east. You can see that warm water advecting up to the surface, and then it gets caught by the trades and starts getting dragged back to the west. All this looks exactly like what you'd expect during El Nino. Another version of that using different technology, using sea height data to estimate how much warm water there is at depth. Warm water at depth, if you have warm water at depth, it's expanding water. It'll displace and create a bump on the ocean surface. Cold water contracts, it'll create a divot on the ocean surface. We'll go look at the chart in a second on that. But the inference is, here is your big Kelvin wave, the date line right there, with, what do we got? 1, 2, 3, 4, 5, if not 6. 1, 2, 3, 4, 5. 3 to 4 degree above normal temperatures here. And this water warms as it starts moving up higher up the thermocline. So that's Kelvin wave number 7, Kelvin wave number 6, and it's probably pieces from numbers 4, 5, and 3, all balled up here off of Ecuador, waiting for their chance to get to the surface. You see some of the fingers of it reaching up here. You'll see that in a minute. All this is just, and more flowing off the maritime continent here. A continual Kelvin wave production machine in flight, exactly what we want to see. Sea level anomalies. Again, this is what we were talking about earlier. This is a satellite, rotates around the planet, looks at the height of the ocean, takes out the waves, the wind waves, even the tides, and is the sphere of the ocean higher or lower than normal? If you have warm water at depth, like I said before, it creates positive anomalies. So let's get oriented here. Chile, Peru, Ecuador, the Galapagos right there. There's the equator. There's the date line. You see Central America there. But you see this big area of positive anomalies from, we'll just get there, about 165 east, almost the whole way into Ecuador. Now displaced off the coast a little bit. Not surprising. Trades are blowing pretty hard here. The warm water, not fully, completely east-based, but east-based enough. California is at 120, and there's plenty of warm water even east of California. This all suggests that this is like a machine to feed the jet stream into California. And back to the folks that live in Texas and Arizona, I would say, do not be disheartened. I know it's dry there, and I know you're not getting the rainfall you want. But at least looking at the data, and this is no promise, but it looks like as we get deeper into the winter, a well-fed jet stream machine should be in place, driven by piles of warm water sitting at depth. 0 to 5 to 10 centimeter anomalies over a thousands of miles of ocean. This is all subsurface now, but all this water has to come up to the surface eventually, and it's going to over the next 4 to 5 months. Upper ocean heat anomalies. So this is just the ocean temperatures in the upper 300 meters of the ocean surface, just looking for signs of Kelvin waves. So we go back a year ago to November of last year. Here again, all your cold water, this is the East Pacific here, West Pacific here, all your cold water here in the East Pacific, all your warm water in the West Pacific, nuking trades, holding the warm water at bay in the East. And then as we got into December, first little active phase of the MJO created a Kelvin wave. Didn't do a whole lot, just a little dribble of warm water. La Nina tried to come back, and then Kelvin wave number 2 right there, making it the whole way across. Number 3 there, number 4 there, number 5 there, number 6 there. And here is number 7 developing on the date line in that region. Piles of warm water all bound to the east. And if we get another active phase of the MJO, which the models suggest as we get deep into December, we'll probably get Kelvin wave number 8. After that, I think we're probably done, but that will be enough. That is your classic El Nino picture right there. Sea surface temperature anomalies, all right? Let's just look at this. Chile, Peru, Ecuador, Central America. Oranges and reds, warmer than normal temperatures. Very good, solid signal now developing. Remember those little fingers of warm water we saw popping up from deep in the ocean? That's likely what these are. Warm water erupting. Now, not exactly along Ecuador, but certainly along the Galapagos in this area. And here's California here. All this is well east of California, suggested plenty of energy to drag the jet stream across these southern tier states. Also notice warm water building almost, not quite in a continuous stream the whole way out to the date line, though. This is looking much better. Last week started looking good. This week looking even better. It was kind of sparse out here. And we got another chart we'll look at in a second. But all this is just the classic El Nino signal. You want to see a triangle of warm water going like this. And here we go, looking solid. Here's the trend for the past, 7 days? Warm. There's those little pockets showing up right along there. Not a whole lot, but clearly, I mean, everything else pretty much holding neutral. Green is, dead neutral, but a warming trend in pockets. I mean, it can't get a whole lot warmer, unless you're going into super El Nino status. We don't think we're going there, but all this is just, again, confirming the push towards El Nino. And then the backed off view, clearly, look at this. The building, what's really impressive, even though that's impressive, that's solid, but the building out here towards the date line, another really good sign suggesting this El Nino is finally getting some legs and starting to move in the right direction. Sea surface temperature trend in the Nino 1.2 region. This is the area on the equator right there near the Galapagos and Ecuador. Temperatures actually slowly trending down as more warm water starts dragging its way by trades out into the West Pacific, into the official El Nino monitoring region. Today, that dot right there at plus 1.731, so actually coming up. You see, we were at 2, and at one point back in August, we were peaking at like 3.1 degrees. I mean, just cooking warm. We're heading downward, but the good news is we go look at the Nino 3.4 region. This is the region from south of California out to almost the date line. This is the official El Nino index, or temperature index. Actually, these numbers run about 0.2 of a degree below what's going on officially, but today's value plus 1.352, but we were up at 1.45 or something here for 5 days a little bit ago, and the trend steadily upwards, exactly as we'd expect. The weekly official record OISST data, so this is Nino 1.2, this is Nino 3, Nino 3.4, and Nino 4. This is the official region. So we had temperatures up to plus 1.7 degrees towards the end of September. They backed off a little bit, but not as much as the models had said they would. And now they're trending upward, and all the data we just saw says they're going to even trend upward from here. The question is, can we get ourselves, how close to 2 degrees can we get? I don't think we're going to get there. 2 degrees is the dividing line between strong El Nino and super El Nino. And just to be clear, 0 to half a degree above normal is just neutral. Half a degree to 1 degree above normal is weak El Nino. 1 degree to 1.5 degrees, which is, we're even above that, that's moderate. So we're at the low end. 1.5 degrees to 2 degrees is considered strong El Nino. So we're right on the threshold, we're in the bottom tier of strong El Nino and building. So looking good. Temperatures you can see in the Nino 3.4, in the 1.2 region here, the anomaly here. We were up at 3.4 at one point. Now we're down to 2.6, but that warm water is building off into this area. And notice the out towards the date line, these temperatures continue to build as well. All a very good sign. And you can see that trend pretty well defined here. We're going back a year. This is the whole way West Pacific, East Pacific here. There's your La Nina cold water thing back last December and January. And then you can, this is at the surface. This is not subsurface. So you can't see the Kelvin waves hitting, but you see the impact of the first Kelvin wave hitting off here in February, creating warm water off Ecuador, getting caught by the trades. And then more Kelvin waves building the expanse of the warm water. It takes multiple Kelvin waves. We're 6 Kelvin waves in, and notice though the building area, and so let's see if we 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's the 2-degree line. That's the super El Nino line there, but that would have to build the whole way out to somewhere like here. Don't know if that's going to happen. More likely it's 1, 2, 3, 4. This guy, 1, 2, 3, 4, which is the strong El Nino. Well, I think it seems quite likely. You can even see it there and there. These just two shadings need to connect. That should probably happen within the next month, and we would be in strong El Nino shape. It is kind of interesting considering how much warm water there is at depth and that there's more Kelvin waves in flight, and that looking at this, I mean, I look at the models, and we'll look at it in a minute, and they say one story, but you kind of almost, I don't want to hype anything up here, but it kind of makes you wonder if maybe this El Nino is just very slow and evolving, but it seems like there is some very strong fundamentals going on here. Now, especially after we got past that slow pause that happened in June and July, I mean, it kind of seems like we're off to the races. I'm not seeing anything that's really telling a particularly troubling story at this point. All right, so here is our temperatures. I'll drag this down just so you can see November 3rd right there. This is what's going on right now. You can see the building warm pool. How does this stack up to other El Ninos? All right, so we'll just do this. Here is 2015 El Nino. Well, we're actually way stronger. Look at this. In this area, way stronger, way more east-based than 2015 at this exact same time. And I'll pull it down just so you can see it. November 3rd right there. Okay, I'll pull this back out of the way. But there is more warming out here. This suggests that what we're in now is more east-based compared to the 2015 El Nino, which was reasonably east-based. I mean, there's California. If you're anywhere, if your peak warming is from here inward, you're in good shape. Now let's go look at 97. November 3rd of 97, you can see it was talk about east base, talk about warming, and even hard warming out here in, southeast of Hawaii. That is a major east base El Nino. 2015 can't compare to that, and 2023 can't compare to it either. But at this point, 2023 almost looks stronger than 2015. Other data says not, but I suspect, again, and I might just be chumming the water here, that this El Nino is slow building and its character has not been revealed yet, but it might be as we get deeper into January. All right, so what does the atmosphere think is going on? We look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, over in the Indian Ocean, and Tahiti, squarely, at 140 west, so basically south of Hawaii in the Pacific Ocean. All right, if pressure is lower in Tahiti than Darwin, the index will go negative. Well, today it's pretty much neutral, 1.46. What's been going on for the past, well, look at this, neutral, 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 through till about October 23rd, and then it was just, we had a lot of good negative. In fact, we had a 65-day run of well negative numbers. Now we're sort of sitting neutral, but it's no coincidence that the inactive phase of the MJO is occurring right in sync with all this. So we talked about the inactive phase of the MJO destructively interfering with the El Nino base state. That's probably what's going on here. And it's not destructively really doing anything. We're just sitting at neutral for a little bit. We've got, what, another week and a half of the inactive phase, and then my bet is this is going to be off to the races, and things are going to get even more interesting. 30-day average here. We'll pull this over so you can see that a little bit better. 30-day average. Okay, we're at minus 6.09. For this to be like fully raging in the peak of El Nino, I think I've seen it down as low as 25 and pretty consistent for a week or two. Where are we at? Well, we were at minus 13. We're actually going in the opposite direction. Again, I think that's attributable to the inactive phase of the MJO. And then the 90-day average. This is your El Nino La Nina indicator, but it's 3 months delayed. So you're really looking at what was happening almost 3 months ago. So we're at minus 9. You want to be at minus 15 during the peak of your El Nino. We were down to minus 11.5. We've lost a little ground. Again, inactive phase of the MJO, likely the influencer there. Certainly nothing to be concerned about. The 30-day moving SOI graphed out. All right, if you're above the line, roughly speaking, you're in La Nina. If you're below the line, you're in El Nino. And then notice the squiggles, the ups and downs. Downwards are the active phase of the MJO. They run for 4 to 6 weeks. The upward squiggles are the inactive phase of the MJO. So in January 2021, we were in La Nina. The inactive phase of the MJO was stronger than the active phase, driving the average high. And then January this year, active phase of the MJO nonstop took us on a deep, deep dive. Inactive phase of the MJO, another active phase. We were this is the stall that we talked about, where El Nino development stalled. We're not stalling anymore. This is the current inactive phase of the MJO, but I think this guy's going to be off to the races in about 2 more weeks, and we'll be in a very good place then. In fact, things are going to get really interesting. The CFS model forecast for sea surface temperatures in the official El Nino monitoring region, the Nino 3.4 region. So where are we? We're approaching the middle of November, which would be about right here. Temperatures, according to this model, about 1.55 degrees above normal. That's about where we are. The forecast temperatures going up to 1.9 degrees above normal, but the official El Nino reading is over 3 consecutive months. It's the ONI, they call it. So if you were to pull 3 months out of this from here to here, this looks like, maybe about 1.65 degrees, if you believe the model. Now, this is the unchecked version. Here is the PDF corrected version. It says temperatures only getting to 1.6 degrees above normal. I don't believe that at all. And if you go look at the consensus model, it only updates once a month. We looked at it about 2 weeks ago. It suggests a bunch of the dynamic models have temperatures at 2 degrees or higher. Again, I'm not saying that's going to happen, but the CFS model, this one right here, is probably on the low side. And I'm still kind of hanging. Maybe we'll get a little spike here above 2 degrees, but the average, the 3-month average, it'll probably be somewhere around 1.7 or 1.8, I'm guessing. All right, so let's sort of wrap up where we are. El Nino's status, developments. Clouds continue building near the dateline, and they have been, and it's getting pretty obvious now. It's showing in the models, it's showing in the actuals. We're actually getting winds that appear to be the convergence point somewhere there near the dateline. Equatorial current continues suggesting Walker circulation effects at the surface near the dateline. I didn't pull up the actual current chart this time just to try to keep things shorter, but there's been no real change. The NPac jet stream is building and further south, and that we saw that. It's clear it's atmospheric river poised for Northern California the early part of this week. That's all good news. The SOI, the Southern Oscillation Index, is neutral because of the inactive effects, or the effects of the inactive phase of the MJO, but we think that's going to be short-lived. West wind anomalies fading some over the Kelvin wave generation area, but forecast to build strong. Again, inactive phase of the MJO probably having an impact there. More developments. Kelvin wave number 6 erupting and Kelvin wave number 7 building, and strongly so. And active MJO number 8, well, I wasn't even counting what's scheduled to happen over the next 2 weeks with that massive westerly wind burst forecast. But if that happens, I mean, I think it's just going to make Kelvin wave number 7 really big. But then, yeah, there's another active MJO forecast as we get into December. So maybe yet an 8th Kelvin wave or just a continuous flood of warm water pushing to the east. All the ENSO models suggest more of the same moving forward. And if anything, the CFS version 2 model is a little bit on the weak side. Projections. Walker circulation, it is building and it's going to continue building towards El Nino. It's real evident now. West wind anomaly pattern to continue over the Kelvin wave generation area for sure. At least one more active MJO Kelvin wave forecast or two. Ocean and atmospheric coupling to strengthen. Yes, we finally have atmospheric coupling. I think I got a question about that from someone too. Well, how do you know when it's El Nino? I mean, the models say El Nino. Some people say, some sites say we're in El Nino. I was slow in saying that because the atmosphere and the ocean weren't coupled, but now we're seeing pretty good solid signs of it, specifically around the Walker circulation, the building cloud cover pattern on the dateline. The SOI going negative in 2 weeks will be the final icing on the cake, but I'd say it's safe to say we're in some sort of an El Nino state right now. It's only going to build. I think it's going to be delayed and take longer to really get to its peak compared to other El Ninos, which normally peak out somewhere between Thanksgiving and Christmas. I wouldn't be surprised if it's the end of January or early February till this one peaks out. So that suggests a slower start to the season surf-wise, but man, when it comes, it should really come. Peak ONI projection, I'm still hanging in the 1.7 to 1.8 degree range. If you think differently, give us your thoughts in the comments section. So all the technicalities aside, there are gales producing winds blowing on the ocean surface, creating seas. Not huge, but steady swell, it looks like, is starting to set up in the Pacific, focused on the Gulf of Alaska initially here, but then maybe moving to the North Dateline range later in the week. Swell for all is expected. Hooray, it is about time. And it looks like some rain into California, maybe even some snow for the Sierra. My guess is as this inactive phase passes by and El Nino really comes roaring to life as we go 2 to 3 to 4 weeks out, things are going to start really getting interesting. Full El Nino is in the forecast. Strong El Nino. I'm not saying super El Nino, but certainly a strong El Nino, pretty much like what we've been saying all along. But all the worry about the coupling and the stall and all that stuff, I think that's pretty much behind us now. And we are on, the train has left the station and it is moving in the right direction. Now we're just going to watch and see, 1, are our personal projections correct? 2, are you in shape and ready to manage the swell when it comes? And 3, then of course going surfing and actually making the most of what hopefully is going to be a pretty fun looking season moving forward. All right, so that's the video for this week. If you have not subscribed, again, please subscribe. You just click that the Stormsurf icon in the lower right hand corner of your screen. If you enjoyed the video, we always appreciate a thumbs up. If you'd like to make a special donation, you can use the special thanks button down below, the heart with the $sign in it. Any of you have questions or concerns, write them up in the comment section. We'll be happy to reply and try to explain what is a very deep and technical subject. And with that, we are done. We're over an hour again. Oh well, tried to make it less than an hour, but we still ran over. That's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.